Hello everyone, my name is Kaito Sugimoto at the University of Tokyo. In this presentation, I'll talk about incorporating the rhetoric of scientific language into sentence embeddings using phrase-guided distance supervision and metric learning. Scientific articles explain new ideas or discoveries and attempt to convince readers of their importance. Sentences in a paper often play argumentative roles within the document. For example, a sentence beginning with the phrase "little attention has been paid to" shows a lack of previous work on the topic of the paper. We call such roles as communicative functions or simply functions. In this paper, we focus on developing a sentence representation model for communicative functions. Sentence representation is one of the fundamental tools in NLP. However, traditional models are usually based on the lexical similarity of sentences, thus not suited for detecting functional similarity. If we can incorporate functional similarity into sentence embeddings, we expect to improve applications such as paper recommendation and writing assistance, which are currently done on traditional embeddings. We first addressed the scarcity of fine-grained sentence datasets with communicative function labels. Our solution is to construct a pseudo-labeled dataset using distance supervision. Specifically, we utilize academic phrase bank as a dictionary. We retrieve a huge number of sentences from the stored dataset and then conduct phrase matching with academic phrase bank. Phrases in academic phrase bank tend to be lengthy and sometimes contain content words that are irrelevant to the function. Therefore, we extract every n-gram from the phrases. These n-grams are used as queries for automatic labeling. The resulting dataset contains more than 100,000 labeled sentences categorized into 77 classes. Then we train a sentence representation model by fine-tuning Cipher. We take sentence embeddings from CLS output layer and train models with metric learning objective. We explore 5 different metric learning losses, including traditional methods such as softmax loss and triplet loss, as well as state-of-the-art methods such as arc-based loss and MS loss, which are originally proposed in computer vision but also applied for NLP. We conduct sentence retrieval tasks on 3 evaluation datasets. We measure to what extent sentence embedding models can retrieve functionally similar sentences. The results are shown in this table. Among the baseline models, Cybert and PubMedBird achieved the highest average scores. These domain-specific models consistently outperform BERT, suggesting that pre-training on scientific text has a positive impact on learning functional similarity. Our proposed model yields further improvements over the baseline models, illustrating that our model can effectively retrieve functionally similar sentences. We also compare the performance differences between 5 metric learning objectives and find that recent methods do not perform better than traditional methods. Using our model, you can easily compare 2 different papers. This example shows comparison between the paper that proposed BART and the paper that proposes BERT. Although these models have different backgrounds and different architectures, you can see that there are some sentences in these papers that have the same rhetorical feature. Our code, data, and trained models are publicly available on this link. These are the references. Thank you for your listening.